And we're recording. Good deal. So that fixed the problem. Okay. And so since we're recording here January 25th, 2023, this is a remote learning day for Rankin Technical College. We had a little bit of snow in the area, and so um, we're working remotely today. And what we have on the syllabus is a lecture on chapter 5, so we are not going to fall behind. What I want to start off on this recording and remind anybody who's watching this in the future or listening live that to be marked present for today, there's basically two requirements. The first requirement is that you're online on Discord and participating, during the class duration, 8:05 to 11:55. And then part two is that you have to turn in an assignment for the day. And that assignment is the Chapter 5 written test. That Chapter 5 written test is active and online on Inside Rankin. And it is due at 8:05 a.m. tomorrow, January 26th. So it's due by the start of class tomorrow. Okay, so got to be here, got to be active, paying attention. Um, part two is turn in that assignment, and you should be good. Now, chapter 5, it's always good to talk about the importance of a topic before we get into a topic. Um, if you look at chapters 2, 3, and 4, it's really getting used to fundamentals of C sharp. It's getting used to variables. We spent a lot of time talking about declaring variables and initializing variables. Spent a lot of time talking about the different ways that you can write C sharp. So far, we've written C sharp in both command line apps and what are called Windows Form app. Excuse me. And a lot of these just kind of more fundamental things. Um, Chapter 5 deals with what are called control structures. And so, what that really means is if statements. And we're going to get into if statements and what are called switches, um, as well as some loops. And so, control structures, if you think of a control structure on a highway might navigate your traffic into one lane, right? So you put some cones on a highway, or some signs to merge lanes from two lanes into one. It kind of controls the flow of the traffic. And that's exactly what they do in code. Control structures control the flow of your code as it's executing. And that's exactly what these if statements and switches and loops will do for us. And so um, we've kind of hit some basics of C sharp. As we get into these different what are called control structures, and yes, everything here is categorized as a control structure. These are the concepts that when people who say, when I talk to employers, they say, I just really need someone who understands the fundamentals of writing code. And yes, when they're talking about the fundamentals of writing code, they're talking about if statements, they're talking about loops, they're talking about declaring, variables with data types. But the point is, a lot of times, just these fundamentals are what employers are looking for in someone if they know how to code or not. Um, as an employee of Rankin myself, when I hire someone, like we're interviewing right now, literally tomorrow, we have an interview for an instructor to teach coding. And we give them a coding challenge to make sure that they understand these fundamentals, um, such as if statements and loops. And just as you guys might want to be aware, as people who will probably take coding challenges, this is a very common one. In fact, this is one that we give at Rankin. Is this kind of very standard problem called FizzBuzz, and FizzBuzz is a name of a coding challenge that you should be able to code and demonstrate for an interview because it will demonstrate the fundamentals of these loops and these control structures. So, just hit up the FizzBuzz Wikipedia. Maybe we should just do this as an exercise sometime. It's definitely not a bad idea um, to kind of prepare you for these coding interviews that sometimes and oftentimes you'll have to pass. Um, so to get into this, it's I don't know what else to say. Why is this important? Because it is absolutely a fundamental of coding, and regardless of whether you're writing C sharp or Java or C++ or Python or some sort of you know, command line utility that has some sort of loop in it. I mean, this is just in every language. These control structures, you'll study them in C sharp, you'll study them in JavaScript, you'll study them in any language that's out there, that's a modern day language, right? So um, they're just absolutely fundamental. So we get into them. At least we are introduced to them in in chapter 5. Okay, just hit pause there to reply to some situation going on. Let's get back into the lecture. So where we left off was really just a um, beginning of. I'm going to jump ahead to slide 8 to talk about this control structure called an if statement. And I'm just going to demonstrate this with code. And so I'm going to open up a Visual Studio community, and I'm going to create a new project, and I'm going to select desktop app. This is a Windows Forms app, and let me kind of go into GitHub. I already brought in Atticus's lab just as my demo. This is chapter 5. We'll call this class demo 1. And we'll spin up something to write some code in. While this is spinning up, I've been teaching if statements for a long, long, long time, and to many different students, many different classes, many different years. The thing that makes the most sense to me, is, as long as I've been teaching this, is to say that an if statement is the control structure. It is the code that makes our programs smart. And so we have smartphones. Well, literally, you can make them smart because of these control structures. Um, what if statements allows us to do, really literally, is have smartphones and have smart TVs and have smart appliances. What does it mean for these phones to be smart? Well, it means that depending on depending on some data, depending on, you know, uh, maybe just as an example, your smartphone is smart because you can open it, click on an app, and depending on the weather outside, It can tell you uh, what the forecasted weather is. So depending on conditions, there are conditions, there's some data that is tested, right? Like, what is the current weather outside? And your phone can tell you what's going on with the weather. So there are conditions that happen in everyday life that we as human beings, we look at conditions like, oh, it's snowing outside, we better cancel school. So, you know, I could write that if in an if statement, if snow outside is heavy, something to that extent. If the snow outside is heavy, then the behavior is cancel school equal to true. Okay? So, again, to try and make this more concrete, as human beings, we make decisions based on conditions. And those decisions allow us to be smart. They allow us to make smart decisions. Our decisions aren't always smart. Sometimes our decisions, you know, are the opposite of smart. Sometimes our decisions are in fact dumb. Um, and but making decisions based on conditions allows us to make smart or dumb decisions. Just like our phones, we call them smartphones, but in fact they can also be dumb sometimes, right? They can lead us in the wrong direction depending sometimes on the answers or the decisions that they give us. So I hope what you're taking out of this is that if statements are a very powerful control structure that allows us to write C sharp and any language to make our programs make smart decisions, you know, uh, to mimic the actions of a human being. You know, if human beings can make decisions based on conditions, so can our software. So the syntax of an if statement, you can kind of see it there, but the syntax of an if statement, let's generate an event listener for this button click. Is like this. At a most basic level, we've got the keyword if, we've got some parentheses, and we've got some curly braces. So this is an if statement in its most basic form. The keyword if, and then parentheses. And so what goes inside the parentheses is the condition. Okay, again, human beings make decisions based on conditions. What goes in the parentheses is the condition. This condition is called a Boolean condition. Someone remind me what it means to be a Boolean condition. Let's get a little.
True or false?
Yeah, true or false. I'm not sure who said that, but they said it correctly. A Boolean condition means it must evaluate to true or false, meaning it must evaluate to true or false, right? We can all take a look at if 3 is less than 4. Okay, that's true, right? So 3 is always less than 4. So it's kind of a silly if statement because this is always true. But let's just say we were to ask the user, their income. If I were to drag a text box, if I were to drag a text box here, and I would call this text salary, txt salary, and I were to draw a label here to prompt the user to enter their salary, So if I go to the text property here, there it is. Enter your salary. Okay. Now we can get some dynamic data coming from the user. So let's read that. We'll say salary is a currency. We mentioned that we should store currencies in the decimal data type. Decimal user salary equals convert to decimal text salary dot text. Okay. Now, if you did your labs from the last chapter, this should all kind of look familiar. We're reading the text property out of a text box called txt salary. We're converting that to decimal on the right-hand side of the assignment operator and storing that in a variable that's camel cased called user salary. Now we can use this user salary. If user salary is greater than 100,000, we can have an output label, congratulate the user for a high salary. So we'll delete the text property and let's give this a name. I always over scroll things, so forgive me. There's the name. We'll call this LBL result. And here, if user salary is greater than 100K, LBL results dot text equals, let's put a little what you would call string interpolation, right? Your user salary colon C, your salary is above average for the STL region. Okay, now you go to Silicon Valley, you're underpaid, but you'd be paid pretty well in St. Louis if you earn that kind of salary. Okay, so again, what does this do? Well, read the input from the user is what this line is doing. And now we have a very basic if statement that'll test why is this a control structure. Well, line 23 will never run if the user salary is less than 100,000 or even 100,000 itself. It's not greater than or equal to 100,000. It's greater than. So it's not inclusive of it's not inclusive of 100K. I got a lot of stuff running on my computer right now, so it's not the fastest, right? So if I put in a 500, 1, 2, 3, 4, 5, 6, your 500, well, I think I put 5 million, whatever. Your giant salary is above average for the STL region. Okay, nothing groundbreaking or revolutionary there, but if you've never seen an if statement, that's working as intended. Let me ask the question, if I go back and all of a sudden I say 20K, and I click the button, my label still says the same thing. Anyone see a problem with that? I mean, obviously that's a bug, right? Any thoughts about how I might go about fixing that?
An else statement?
Okay, so one potential answer there would be an else statement, and that is correct. But before I get into an else statement, what you might do is at the first line in my. This is another solution because I don't want to talk about else's just quite yet. I just want to point this out that on line 12 here of my button click, I could clear my label. Clear the label to an empty string. And an empty string will just make that text disappear. And so if I put in the big salary, okay, and then I come back in and I clear it, okay, it just goes away. And so now if I put in big salary, I get the message. If I put in anything less, I'm not getting anything. And the way this works is this line executes every time. This is not an if statement. Okay. And so, man, it's very important that we understand an if statement at its basic fundamental level. If statements allow our programs to be smart by making decisions based on conditions. The condition goes inside of these parentheses. The condition is called a Boolean condition, or you might hear it called a Boolean expression, meaning this has to evaluate to true or false. So what goes in the if parentheses must evaluate to true or false. And then if it's true, the decision that's made is to print out line 27. It's to execute line 27. So the decision that's made in this, if this is true, this block of code is executed conditionally. Meaning, if the if statement is true, this block of code will run. If it's false, then this block will not run. Very simply, it will not run. So this is the decision that's made based on the condition. Okay, a decision is made based on a condition. This morning I got out of bed. I made the decision to get out of bed, based on the condition of, I go to work and ultimately I get a paycheck. Under the condition of getting paid, I made the decision to wake up, put on a polo, and go to work today. And today's in my basement, but you get the idea. Okay, as a human being, I made a decision based on a condition. Now we can write software that does the same thing, that makes our program smart, and that's a very powerful thing. Am I beating a dead horse yet? A little bit? Now, it is worth noting that this if statement doesn't have to be any more complex than this. Very quickly, after learning a simple if statement, the logic, or not the logic, the next control structures will become more complex, aka if else, aka if else if, else if, else if, else, aka nested ifs. And so it's one thing when you say, hey, I've got this if statement by itself, And that's not super hard to learn by itself. But unfortunately, the real world is full of much more complex problems than what I just put on the screen here if the user salary is greater than 100K, right? The world is full of very complex problems which need more complex control structures to solve. And so it is worth noting that there can be an if statement just by itself, and that's where your learning needs to start. You need to start learning this if statement just by itself. And if you understand this if statement by itself, you will need to practice it, and that's where the labs come in. But then very quickly, we need to solve some real world problems. You might need and probably will need more than just an if statement. You'll probably need, like I said here, if else statements. If, else if, else if, else if, and these else ifs can go on as long as they're needed. And then an else. Nested ifs. There's another one called a switch. And so if you didn't pay attention the first 20 or 30 minutes, whatever this is, and you just kind of jump in and all of a sudden you see if, else if, and all these nested ifs and all this kind of stuff, you're going to get overwhelmed. If it's a simple real world problem that you're solving, you might only need an if statement. But a lot of times the real world is more complex than that, so you need more complex control structures that we're going to continue to talk about. The slide right here talks about the different ways that we can compare. These are called relational operators. And so relating two pieces of data, user salary greater than of some value. Well, of course, there's less than. Of course, there's greater than or equal to, less than or equal to. These are all acceptable values. The one that messes the most people up is to see if user salary is equal to something. Beginner programmers always make this mistake. Notice right here, and please everyone pay attention to this, the double equal sign is a test. So I'm going to write a note here. Double equal sign is a testing operator. You are determining if one thing is equal to another. A single equal is, what is that operator called? It's not a testing operator, but the single equal is called the, open it up someone, not all at once. It's fun to be remote. Come on guys, someone say something.
Hold on, I'm looking through my notes.
Alright, well I appreciate some feedback. You could
Is it a binary operator?
It's the assignment.
Yeah, I heard it. It's the assignment operator. Remember when we said int x equals 2? We're assigning the value of 2 equal to x, right? So you're saying put the value of x inside of this variable. So there's a big difference between a single equals and a double equals. The double equals is a test, whereas a single equals is an assignment. Okay? So this right here, what beginner programmers tend to do on line 31 is they write it like this. And thankfully, this actually gives us the compiler errors nowadays. This actually used to compile And so, because it was such a common mistake, it cannot do this, right? It says it cannot implicitly, or you remember, automatically convert decimal to bool. It needs to be the double equal sign. Okay, so going back here, and then the last one that I didn't mention is not equal to test if a user's salary is not equal to a value. So I'll say if your salary is greater than or equal to 100K, then we print that out, and we've covered a lot of theory. Okie doke. The next thing, as someone alluded to, is that oftentimes when you see an if statement, you see this else block. Okay, and this is really important to understand too. This is really fun, foundational, before we expand into more complex things. Okay, so let's get everyone to zone back in, and we could talk about the else block. Now, if you view the if statement as your true block, the else is your false block. So this is what you're running if the if statement is false. Okay, the if statement block is what you run if it's true. The else is what you run if it's false. Please take notice. Please notice there are no parentheses. I can't spell. Parentheses. Can't spell. We're just going to stay with that. There are no parentheses on the else block. So right here on line 40, this is not correct. When you see the if statement, that's where you put the parentheses. So if I were to have an else if, I would put parentheses. But if there's no if it's just an else, there's no parentheses. There's no condition to test. The else, the condition is above. The condition is on the associated if. And if that if is false, you don't need to evaluate another condition in the else block. So please notice there are no parentheses on the else block. Where that gets a little confusing, and I'll just kind of code up another thing down here, is you say if this, else if that. Okay, well these parentheses belong to that if. They do not belong to that else. And then you can have another else block down here that doesn't have an if, and this else block does not have parentheses. Okay, this is kind of where we're going. Okay, but this final else block that does not have an if does not have parentheses. Okay, so again, common beginner mistake is to want to put parentheses on this else block. That is not correct. So if the user salary is greater than 100K, else label result dot text equals, and I'll say your user salary is not above average for the STL region. Okay, so it's either going to say it's above average or not above average. And probably that number is a lot smaller, right? So probably we're going to say, 70K, 70,000. Again, beginner mistake. There's no commas here. Very common mistake is to want to put commas there. There's no comma. So let's go ahead and debug this. So I'm either going to get a true or a false output here. All right, and again, remember I changed the line to 70K, so 800K is of course greater than. 80K is of course greater than. Let's just throw in the number 70. It is greater than or equal to 70. So 70K is above average, but 69,999 is not above average. So anything below 70K, like $700, $50, 500, $50,000 is not above average for the reason. So that's what there is to know about an else block. If it's black and white, true or false. True block is the if block, false block is the else block, and if your scenario is in fact black and white, true or false, then you can use this control structure to give you one output or another. Your software can make one decision or another. The application of this and how if statements are made, this is at the foundation of all software that you've ever used, right? Doesn't matter. Facebook, Instagram, your cell phone, your laptop, all the software you've ever used in your entire life, if it's part of a computer, behind that software, there are these little control structures, these little if-else's going on, making decisions based on the input that you're giving it, right? If your friends on Facebook display their news feed, display their statuses, okay? So again, super foundational control structure that we need to learn as software developers. So I hope you guys are awake and engaged this morning, because this is really good stuff, really important foundational stuff. We are at a point where I like to give a normal time for a break. So I'm going to go ahead and pause. And so we're going to resume and bring this example, take these comments down a little bit because they clutter things. And so the next step in learning these if statements is to understand the else if statement. And so first we learn the if, then we learn the else, now we learn what's called an else if. And so let's just kind of go back to our original example. If your salary is greater than 100K, your salary is much above average. Let's see, is greatly above average. So if you earn more than you're greatly above average for the St. Louis region. Okay, well, here's another scenario. Else if user salary greater than or equal to 70. You're not greatly above average, you're just a little above average. So we'll say label result.text equals we'll just say above average. Okay, well now there are just basically more conditions that we can meet. We could say, okay, if it's greater than 6 figures, else if it's, this kind of creates a range. If you think about it, if it's greater than 100K, 200K, 300K, 400K, all those conditions are met. Else if it's basically below 100K and above 70K. So a lot of people would code it unnecessarily and user salary is less than 100. Well, you're already essentially testing for that here. And so you don't need this and in some cases. If you code it in this manner, you test for everything greater than first, then you say, okay, is it greater than 70? And so now if we say our salary is one thing, above 100K, we'll get one output, but if we say 80K, we'll get another output. And so it allows us to make decisions based on more conditions. We're adding conditions. Right? So that's greatly above average, but if I just say 90K, well, 90K is less than 100, but greater than 70, so it says you're just above average. And so more conditions are being tested if we do these else ifs. Else if user salary is greater than or equal to 50, we can say label result.text is average. So between 50 and 70, it's an average salary. Else, and this is for everything beneath 50K. I don't know where the line is. That might be a little high actually, but that's not the important thing. Is below average. So this is testing for a condition for this block that I'm highlighting. This else block is another condition that's testing for true. This condition is testing for truth. So these kind of first three places here, these are all testing for different truthy conditions. If none of these are true, it'll run the else block and say your salary is below average. So kind of following along here, we got 100K. Our $1 million salary is greatly above. You're 80, you're above. If you are between 70 and 50, so let's just say you're 60, your $60,000 salary is average. But if you got a $30,000 salary, oop, that's one too many zeros. $30,000 is below average, right? And so that's the else if block. And so it becomes what control structures you use are completely dependent on the problem, the real world problem that you're solving. Okay, so depending on the real world, averages, you need to code your problem differently, right? So that's the else if block. Keep in mind the else, no parentheses, no parens on the else block. This is always, always, always the false block. Meaning, if nothing above is true, this block will run. None of these are true, then this is your false block, always. And again, if your real world problems are this complex, and this is the statement that you can use, let's go on to the next one. And we've got maybe two more things to cover, which is nested ifs as well as compound if statements. And then we're gonna stop, and I'll get this kind of. We'll stop for the day with the lecture. Okay. So, back. Compound. Okay, you could say if. So the way this works is you can test for multiple. When I say compound, you're testing for multiple conditions. We'll test for multiple conditions in a single set of parentheses. So, if I bring this back, I shouldn't have deleted my double. User salary equals convert to double text salary dot text. If user salary is greater than. I heard a question. I heard a voice. If user salary is greater than 100, and we need another piece of data. We can do user salary. We probably need another piece of data to make this. Let's bring in a label to enter your name. And let's bring in a text box. Called text name. Okay, because we're putting a string in a string, we don't need to convert anything. Now, if the user leaves that empty, if the user leaves the username empty, it would come across as an empty string. So you could say, and username is not equal to empty string. So if the user were to leave this text box blank, then username would equal an empty string. And so this if statement is testing for two kind of, well, not kind of conditions. This is testing for two conditions. Okay, the user salary has to be greater than 100 and the username is not blank. And then what you can do, label result.text equals whoops. You could use the username as a very high salary of user salary :C. Oops. when you get this running, some of you have seen this, you got to close it from running first and then it'll start running over. Now notice if I could put in a salary here, but I'm not going to get any output because the way these ands work is that to the left, this has to evaluate to true, and to the right, this has to evaluate to true for the overall if statement to be true. So these are called ampersands. The double ampersand means that both the left and the right sides have to evaluate to true for the overall expression, for the overall Boolean expression to be true. Okay, so this has to be true and this has to be true for this block to run. So because I'm leaving the name blank, the username is equal to an empty string, and so I'm not getting any output. But as soon as I put in the name Bob, it said Bob has a very high salary. So this is one compound operator that allows to test for multiple conditions inside of one if statement. And sometimes those are useful. Now, depending on the real world scenarios can get more complex. You might need more outputs in this. Else, you would say label result dot text equals either username was left blank or salary is less than 100K. So the problem with this if-else statement is you don't really know which one was false. Like you could say, okay, if both of these are true, then run this. Otherwise, run that. And that's going to be the output based on the way we have it coded so far. I could put in the high salary, but this says either username was left blank or salary is less than 100K. Well, I could also put in Bob and put in here, but there's no programmatic difference. Like just based on this error message, if I was just looking at the error message and not the input, you couldn't tell, programmatically what is happening. That's where if you need a different response based on these different conditions, that's where this compound operator doesn't really make sense, and we might need to look at nesting if statements instead. Okay, which is where we're going to go next. There's also an OR. Now the OR. So let's talk about the OR before we talk about nesting. The OR, which is two pipe symbols, by the way. If you look at your keyboard, you're going to see above the enter key, there's a backslash, and if you hold down shift, this is called the pipe symbol, and you do two of them. We'll talk about, that's called a short circuiting OR, and we'll talk about what that actually means. But the OR symbol is two pipes, which is this right here. This means either the left or the right expression means if either the left or the right expression is true, then the overall if statement is true. So this reads like this: if the user's salary is greater than 6 figures or the username is blank, then we can say the username has a high varied salary. Now, we would probably change this up because this doesn't make sense anymore. You can't just take the and change it for an or and it still make it make sense. So if the user salary is greater than 6 figures, or I don't know what I want. Again, what I did incorrectly here is I started with the code that I wanted, not a problem that I was trying to solve. I needed to start with the problem that I was trying to solve. So what I could change, I could say, okay, if the user salary is 0 or username is blank, if either one of those, label result.text equals please fix your data. Please fix your salary or name. So we're just going to call either one of those conditions, the salary being 0 or the name being empty. We're going to say please fix your salary or name. I don't need that $sign there, but it should still work. Now, this is crashing because I need to enter a salary. I'm trying to parse an empty string, which wouldn't work. I'm trying to convert it to a double. So let's put in a salary and leave that blank. It says please fix your salary or name. If I were to put in a name and an empty salary, it's going to give me the same error message. Again, just kind of running it from scratch. 0 Bob. Okay, these are both conditions that are considered, bad data. So we're getting an error message. Please fix your salary or name. Now we're properly using an or statement. It's allowing us to compound this. Okay. I think I'm going to go ahead and stop the lecture here. This is plenty of information for one day. And then tomorrow we can kind of pick up what we didn't talk on today is nesting if statements. And obviously we didn't get into switches, we didn't get into loops. There's a whole lot in this chapter. That's why we're going to take our time getting through it. As far as the hands-on is concerned, you're going to see, as far as the labs are concerned, the labs only test us. We're only going over if statements at the beginning part of these labs. And so we're not even touching loops until after Monday. Okay, so we'll stop here for today. That's a good amount of lecture. We have a written test to work on, so that should be open. I'm going to open up the labs. If you finish the written test, you can take a look at the labs for the next chapter.